Hello, and welcome to The Daily Space for July 9th, 2018. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Today we have a variety of stories covering planetary science, and I can tell you want to be here on Thursday. There are a variety of cool stories that are currently under embargo, which means all the journalists are contemplating how we can share this amazing information with you, while knowing we can't do it until Thursday. So, I'm glad that you're seeing that the internet is better and that things are running more smoothly. And yes, today is actually July 10th. Thank you for the correction from the chat. I'm just going to jump into today's news because it's clear that everything else is going a little bit sideways. It turns out we actually have good news involving people who work in petroleum and oil mining. Or I guess oil drilling is perhaps a better phrase. The chat is not there. I'll fix that. There you go. The University of Texas at Austin's McDonald Observatory has been collaborating with the Permian Basin Association. Sorry, that was entirely the wrong thing to move. Can I just get a redo on today? So the University of Texas, Austin's McDonald Observatory has been working with the Permian Basin Petroleum Association as well as Texas Oil and Gas Association. This collaboration is to help make drilling platforms and oil rigs out in the Permian Basin area a little bit safer, as well as not light polluting. If you look at this image, what you'll see is the North Star hanging above the Haughey-Eberly telescope. That North Star, you can see all the other stars in the sky slowly rotating around it. Off to the right, however, there are low clouds that are being brightly illuminated by distant human activities. On the left, there is also the high clouds, but we're able to perceive more of the starlight through the clouds because the clouds aren't getting illuminated from the ground. This kind of photo is used at many different locations to judge the severity of light pollution. Out in West Texas, light pollution comes from cities, it comes from lit up barns, lit up airfields, but a lot of times it comes from lit up oil rigs. These oil platforms often have upward-facing lights that don't actually do anything to, serve the safety of the human beings who might be working out on these platforms. The University of Texas McDonald Observatory has been working with these two petroleum and oil associations to determine what kind of lighting can be used instead that illuminates things as necessary, that reduces glare, that increases the safety of the workers. Basically, they're discussing how do we send the light downward instead, illuminate the ground, make it easier for workers to see where they're walking, where they're working, and not light pollute the sky. Working together, these three different organizations have put together a handbook on correct lighting for oil platforms. These lighting guidelines will help reduce the cost to these different corporations that are drilling for oil because they won't need to spend as much money on electricity since the majority of the photons will be going where they're needed instead of going into the sky where they make it hard for us to do astronomy. We at the Daily Space fervently hope that these new guidelines will be adopted across the world, one oil agency at a time, one oil association at a time, until our skies are just a little bit darker and allow all of us to enjoy the stars a little bit more. So moving on to our next story. As you may remember, back on June 2nd, 8 hours before hitting the Earth, the Catalina Sky Survey detected a small asteroid, just a couple of meters across that was on its way, well, for impact over Botswana. Scientists from the SETI Institute have now gone, well, on safari, not for elephants or giraffes, but instead for rocks from space. I'm not quite sure how they did it, but after gathering information from security cameras, from, well, any camera they could find that recorded the burst of light that was caused by the explosion of the asteroid over Botswana, that could be seen from Botswana and neighboring countries. Using all this different imagery, they were able to trace back to the point of impact to a roughly 200 square kilometer region that is described as uncharted wild, teeming with elephants, lions, and snakes. Exploring this region, they have so far been able to find one rock, one very exciting rock, which I show here in this image. It's unclear exactly how much more they will find, but every piece of rock is a piece of information we didn't have before. And, you know, I'm not sure I've seen a scientist smile quite this big. Again, this is research that is being done by the SETI Institute out in Mountain View, California. These are folks that are doing research to help us understand, well, what is the chemical composition of space in different places? What is the material that came together to form our solar system? And how can we use this information to figure out where out there life might also be found beyond our solar system? So continuing on to look at our solar system, we have a newly released global map of Pluto that allows us to understand the height of various features we find on its surface, and is also just full of amazing images like this mountain range I show here. Now, while it is kind of rich with really pretty pictures, what's more amazing is what this topographic map allows us to do in terms of understanding the surface of Pluto. Here we see Sputnik Planum, a large plain of nitrogen ice that looks like a heart on Pluto's surface. This particular region was stereoscopically observed by two different cameras that had slightly different angles when they took their images of these features. Using this stereoscopic information, scientists have been able to figure out that this particular plain is at its center about 2 kilometers lower than the average surface height of Pluto. More amazingly, its edges are roughly 3 kilometers lower. This is, for comparison, about the depth of the Mariana Trench deep in the Atlantic Ocean here on the planet Earth. Pluto's a whole lot smaller, and seeing this kind of depth variation is truly amazing. And how we explain exactly how the edge of this plane is so much deeper than its center, this is the kind of scientific question that we kind of love to have. So please go out. All of this is publicly available. Data that is paid for by NASA, that is provided basically through US tax dollars. We have a policy of setting this data free and making it available to the scientists and the science community, that's you, of the entire world. So go, find yourself a pretty bit of Pluto, study it, and be in awe of what this world unexpectedly has to offer. Now, in one more planet-focused story, we have a tale of Ross 128. This is a planet that is similar to Earth, but not identical. It is similar in size, it is rocky, but it's orbiting a red dwarf, and this means that its temperature profile is going to be different. How it is affected by its star is going to be different. So we're in this interesting place where we're starting to finally find over and over and over planets that are, well, structurally similar to what our Earth was, how our Earth formed. And experience a very different reality because of the kinds of stars that they orbit around and exactly how far they orbit around those stars. So this is just one more example of a small rocky world being uncovered. This particular one was not found by Kepler. It was actually found as part of the Sloan Digital Sky Survey using the Apogee spectroscopic instrument. So the ways that we're finding planets that are small, that are similar to what we see and what we live upon, well, we're finding more and more ways to do this. So that concludes the stories I have for today. And clearly my computer has decided it is time to begin the binging process, reminding me of meetings I have later in the day. So I do have time to take a brief number of questions as time approaches for me to escape rather quickly at exactly 12:29 so I can sign in for my 12:30 meeting. So please go ahead at me in the chat and I'll answer what I can. And while you're typing those questions, let me tell you, as I tend to always do, that the Daily Space is brought to you by CosmoQuest. We are a project dedicated to get you learning and doing science. Please help us map out other worlds at cosmoquest.org. You can help us find the scientifically interesting places to explore and the safe places to land that spaceship that's probably going to do that exploration. We have projects available for you to map out the Moon, Mercury, Vesta, Mars, and even Earth. We have a particular need for data on Mars and Mercury right now, and once we finish Vesta, we can start in on Ceres. So be like Larry. Larry has finished all the images that we have of Vesta. We just need 14 more people, or a whole lot of people doing the effort that Larry did, to allow us to get 15 people to view all the remaining images so that we can move on to another exciting world. The mapping data will be publicly available once it's fully processed. So just like it took several years, or at least over a year, for the Pluto team to put together their complete mosaic of Pluto, it's going to take us time to put together our complete mosaic of all the craters that you all are working to mark on all of these worlds. The reason for this delay is, well, this is citizen science. This means that sometimes 5-year-olds and cats do the mapping, and we have to do a great deal of statistical analysis to figure out whose data is good, whose data we can't understand, and how to combine all of this input to get the highest quality maps possible. So Hanny is asking, oh man, I thought I turned that off. Hanny is asking, how do they determine that a planet has water on its surface? Well, this is one of the great challenges. This can be done by looking at its atmosphere spectroscopically. This can be done by trying to figure out what its density is, by learning its radius through transits, and its mass by very carefully measuring its rotation speed, which allows its orbital speed, which allows us to get at its orbital radius. By being able to make both transit measurements and spectroscopic radial velocity measurements, we can get at many of the planet's physical characteristics. If we know its density, we can work through what are the standard compositions and how do we mix the rock, the organic material, and the water that go into making a world to replicate the observed density. This is a little bit harder and more likely to be not entirely right, but until we can get there and visit, this is the best we can do. So Keeper of Maps, you are more than welcome to help us on the backside with answering all those different questions. So, do we have any more questions from the chat? And I apologize again for the binging in the background. My computer has decided binging is the theme of the day. I'm not seeing any more questions, I will end this a little bit early so I can get to my next meeting. In closing, I'd like to say this show is sustained by you. We are made possible by your subscriptions. Every little bit matters. Everyone that you see on the show works for a nonprofit. We are led by the Astronomical Society of the Pacific. Dr. Matt, who you see on Wednesdays and Fridays, he's coming to us from the Planetary Science Institute. Big J and Dr. Andreas Plazas are like me at the Astronomical Society. Annie Wilson, she's coming to you from Ward Beecher Planetarium at Youngstown State University. We put a lot of volunteer effort into bringing this to you, and we're hoping someday to have the numbers of subscriptions that allow us to just keep going. So please, if you can, consider a subscription, and once again, every bit really helps. So thanks a lot for watching, and hey, if you're going to be at Alcon this coming weekend, not this weekend. Is it this weekend? This weekend. I will be there with you. So maybe I'll see some of you this Friday and Saturday up in Minneapolis. If you're going to be there, please come find me. I may just have a surprise in my pocket to hand you. I'll talk to you all later. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And remember, we'll be back tomorrow bringing you the latest in space and astronomy. And until then, take a moment to look up. Bye-bye.